Hello dear listeners, my name is Max. I am technical specialist in the CSoft group of companies. In this video, we will learn how to create shells in the PoligonSoft program. For example, we need a shell tool to create a mold. We have a model of a blade in a melting plant. There is no mold for the blade and the filling part. It's more convenient to switch to the mode Show Boundary Indexes, because the mold is created based on the boundaries. Go to the Create Shell tool. We see a window with parameters for creating a shell. We have a choice of the two algorithms for creating the shell. This is automatic and user-defined. We can switch between the methods through the Show Advanced Options tool. We click on this tool and go to the global settings of the program. If we click on the user-defined parameter, then two extra parameters will appear: cell limit per site and number of layers, which are still in automatic mode, but now they can be changed. The automatic method does not always work well, so initially there was only the user-defined mode. First, we need to mark the boundary where we don't need a shell. This is the top boundary for the melt inlet in the filling part. To select boundaries in this way, we need to enable the Select Contiguous tool and select the boundary with the Ctrl K pressed. We need to set a new index to the boundary, for example 2. The index can be anything except index 17, because the casting now has index 17. If we look in the heat transfer properties, we will see that the 17 boundary applies to the casting and environment. Therefore, we set index 2 for this boundary using the Assigned Boundary Index tool. Next, the program suggests creating a volume index of shell. This is an optional step, since we can then change the index. We will put the index 3 for an example. Now we are setting the parameter volume index above inlet area. The shell will turn out to be closed, but just at this step. We will put an hour index on the boundary of the melt inlet in order to then remove the created shell at this boundary. We can put any index that is different from the index used in the parameter volume of shell. We will put the index 9. And finally, we will set the shell thickness equal to 10 mm, and we will try to create in an automatic mode. The program is now making a copy of the volumetric mesh while removing the surface mesh. Next, the program checks the quality and cleans the bad elements, and then the model is sent to the Salon Mesh model to create a 3D mesh. The shell has been created. For clarity, we will switch to the model Show Volume Indexes. The top cover can be removed immediately. A message pops up about setting standard boundaries by default. We say yes. The next step is to check mesh quality. This must be done after creating the shell, because if the program removes bad elements, the shell will repeat the hole, and the mesh will be created incorrectly. Sure, we can fix it manually, but it's difficult. There are only 28 bad elements in the mold. We click on the correct button. The number of bad elements has decreased to 13 elements. We can click the delete button, or we can leave these elements. If we need to create more thermal insulation on top of the mold, we can similarly create a new shell on the previous shell. But if we want to create thermal insulation of refrigerators only in some places, then we can use a similar tool, Extrude Mesh. A window with parameters appears in which we can set the extrude distance and the number of mesh layers by thickness. First, we need to select the boundaries on which we want to extrude the mesh. Don't forget to turn on the tool Select Contiguous. We select 4 boundaries with the Ctrl K pressed. In the parameters, we can adjust the number of layers. We'll leave the automatic mode, that is 2 layers of 5 mm each, starting the creation. Now we can take a closer look at the resulting mesh. As we see, there are 2 layers in thickness. This video ends here. I hope you enjoyed this video. Leave your comments on which video you would like to see in the next video. Bye everyone.